Okay, hi guys. So in this lecture or from this lecture, we'll be starting off a new chapter called Basic Organic Chemistry. So let me write down the heading Basic Organic Chemistry. Okay. So first, we'll be saying what is an energy profile. Okay, so in an energy profile, let's suppose we have a reaction in which the bond breaks and later OH minus actually comes into the picture to attack R plus to form compound like ROH. Okay, and in this reaction, the first reaction is actually the bond breaking reaction is the rate determining step. So if we actually draw the graph between the energy and the reaction coordinate, we would see that so this is how the reaction takes place. In this case, this is the transition state 1 and this is the transition state 2, and intermediary R plus is formed. Okay, and this is the product and this is the reactant. Okay, so in TS1 what happens is TS1 is the bond breaking of happens, and in transition state 2 the bond formation step takes place. Okay, so this is bond breaking and this is bond formation. Okay, so what is reaction coordinate? Reaction coordinate is nothing but the change in energy of reaction with respect to time. So this is change in energy of reaction with respect to time. Okay, so let's delve into the definition of intermediate. Okay, so intermediate, it's a product of for one step of reaction and a reaction for another step of reaction. That simple. So it is product for one step of a reaction and reactant for the another step. Okay, the step which involve the highest transition state in energy profile is the redetermining step. So highest transition is for this transition state 1 intermediate. So this is actually the redetermining step. So to define redetermining step, so it is the step which involve highest transition state in energy profile is the redetermining step. Okay, so let's take an example in which we have a graph something like this. This is the reaction coordinate, and in this graph we have something like this. So this is actually transition state 1 and this is transition state 2. So this, the formation of this is the RDS of the reaction. Okay, so let's say we have this as the graph. So we have, suppose this type of a graph. So let's say this was transition state. Let me define the variables, and then we are going to okay. So in this case, this is the 3-step reaction because 3 transition states are there, so it's a 3-step reaction. Second point is, what are the transition states? So transition states are B, D and F. Okay, and what are the intermediate products or intermediates? Intermediates are actually C and E. Okay, so let us now look at the leaving groups. So let us take some examples here. So we have OH minus plus CS3I, that gives OHCS3 plus I minus. How it happens? This attacks on CS3, delta positive and delta negative, and I minus takes its withdraws its bond from CS3. Okay, we have OH minus here and CS3 Br here, delta positive and delta negative. What happens here is this type of reaction takes place, and we have OH and CS3 plus I minus. Okay, oh sorry, Br minus, beg your pardon. Okay, third is we have OH minus and we have CS3 Br. This is delta positive, delta negative. It attacks on this. Cl withdraws its bond electrons, so we have CS3OH and Cl minus. Okay, fourth example is we have OH minus and delta positive, delta negative. So it should be happen ideally, but no reaction takes place here. Okay, why? Because as we go down the group, the stability order increases, hence this is the most stable and this is the least stable of the all. Okay, so F minus is actually very less stable than on these compounds, and we can actually compare that OH minus is more stable than F minus, hence this reaction does not take place. Okay, and one of the other reason is it is having a weaker bond. The bond between C and I is a weaker bond, unlike in C and F. Okay, so this is the second reason as well. So if you look at this example wherein we have OH minus and CS3 triple bond N on another side. So what will happen in this case is this will react here, this will attack here to form something like this, where we have this plus nitrogen is released. Okay, so it's actually best leaving group. Nitrogen is the best leaving group. Okay, and why it's the best leaving group? Because it's a inert gas. Okay, so this reaction goes forward in very good at very good pace. Okay, and talking about the best leaving groups, so we have actually looked at the stability of the compounds or the products to determine the rate of forward reaction, but again I will reiterate that this is actually the best leaving group. Okay, then comes this, then comes this. Okay, why this is a 3 equivalent RS? I hope you remember the order in which we used to see the stability of the product forms on the basis of the principle called ARHI, AERHI. So based on that only we used to compare, we used to comment on the rate of reaction. So it was AERHI, A for aromaticity, E for equivalent RS, R for resonating structures comparison. And in resonating structures comparison we had, if you remember, we had 4 things, and those were covalent bonds, more number of complete octet, second, of the electronegative element. Third is neutral compounds are given more priority. Fourth is negative charge on electronegative element or atom on in the compound. Then hyperconjugation, then inductive effect. Okay. So let me write it down more formally, that good living groups are those which remove in the form of stable ions, compounds or gases, right? So good living groups are those which are removed in the form of stable ions, compounds or gases. Okay, so weak bases are stable ions and weak base are good living groups. So let's see an example that weak bases are stable ions and they are good living groups. Okay, so some of the weak living groups are, means you can see we have this one. Okay, on phenyl ring we have an attached CS3, so let me write down that also. Let me give the complete structure. This or so the order would be obviously first greater than second greater than third, but still they are good living groups. Okay, and this is known as tosylate. This is known as, which is also OTS. This is brosylate, which is OBS, and this is nosylate, and it is also ONS. Okay, so with this we end our this lecture. And okay, before that let me also write super living group. Let me give an example of super living group. Super living group is OTF. OTF is nothing but triflate ion. So the structure is something like, its structure is something like this. We have F attached to a carbon, and then we have this. So this is a good living group. Okay, so with this we come to an end of this lecture. From the next lecture we will be seeing alkyl halides. So till then, good luck and goodbye.